we will discuss about multiplication of matrices. First of all, we can talk about scalar multiplication of matrices. If A is a matrix and we need to multiply it with a scalar quantity, let's suppose K, then we can denote it by K into A, which can be obtained by multiplying every element of A by K. This procedure is called scalar multiplication. For example, we have a matrix A here and we need to multiply matrix A with a scalar quantity 3. To obtain this multiplication, we have to multiply 3 with all of the elements of A. You can see that 3 is getting multiplied with the first element 1, resulting in 3. Then 3 is getting multiplied with -2, resulting in -6. 3 into 2, resulting in 6. 3 into 0, resulting in 0. 3 into -1, resulting in -3. And 3 into 3, resulting in 9. Let's take another example. For example, we are having a matrix with an order of 3 by 3 and we want to find out the value of -half into A. Therefore, -half will be multiplied with all of the elements of A in the same way we have done it before. So after this, we will getting a result like this. Now here it is very important to talk about a zero matrix. A matrix whose all of the elements are 0 is called as a zero matrix. It may be of any order. It may be like, for example, an order of 2 by 2, an order of 1 by 3. Then we can deduce some properties about matrices. Now, furthermore, a zero matrix is also denoted by O, a big O or 0. So therefore we can say A plus O equal to A, then A plus additive inverse of A or minus A means that I am taking a sum of A and minus A. Their sum will also be equal to a zero matrix. And if I multiply scalar quantity 0 with the matrix A, I would be getting again a zero matrix. Then we can talk about multiplication of matrices. We can multiply two matrices by multiplying the rows of the first matrix with the columns of the second and adding their products. For example, we are having two matrices A and B, and if we want to find out A into B or product of AB, so therefore first we have to multiply the first row of A, which is 3 minus 2 and 1, with the first column of matrix B, which is 2 minus 1 and 3. Now 3 will be multiplied with 2, then minus 2 will be multiplied with minus 1, and 1 will be multiplied with minus 3, and you can see I have taken the sum of all of these products, which is then equal to 5. So we have multiplied across first row down the first column, so we put the answer in the first row of first column in our resultant matrix. So next step will be to multiply first row with the second column as well. So 3 will be multiplied with 4, then minus 2 will be multiplied by 3, then 1 with the 1. And by taking sum of all of these products, we will be getting an answer of 7. Now, as we know that this is the result of multiplication of first row with the second column, so therefore in the resultant matrix, their answer will also be placed on first row of the second column. Now it's a turn of multiplying second row with all of the columns of the matrix B. So now 0 should be multiplied with 2, 4 with minus 1, and minus 1 with minus 3. So their sum of product will be minus 1, and this answer will be placed on second row, first column. Similarly, we have to multiply second row of matrix A with the second column of the matrix B. 0 with 4, 4 with 3, and minus 1 with 1. So the sum of product will give you 11. The answer will be placed on second row, second column. Now you have to notice one thing, that sizes of A and B and the size of the product AB. So we have to discuss something about it. To multiply matrices A and B, you have to first look at their dimensions. For example, first matrix is having dimensions of m by n, and the other one is having dimensions of n by p. Now you can see if the number of columns of the first matrix, which is n, are equal to the number of rows of the second column, only then we can multiply these two matrices. And after multiplication, the resultant matrix will have the order or the dimensions, which will be m by p. So now we can say if the number of columns of A does not equal the number of rows of B, then the product AB cannot be found out. Now let's look at the product BA. Here, matrix B is having dimensions 3 by 2, and matrix A is having dimensions 2 by 3. So first of all, can we find their product? Yes, we can, because the number of columns of matrix B are equal to the number of rows of matrix A. You can see we can multiply because B is having number of columns 2 and A is having number of rows 2 also. And in advance we are aware of that the size of the answer will be 3 by 3. Now let's start multiplying them. First row will be multiplied with the first column. Then first row will be multiplied with second column. Then first row will be multiplied by third column. Similarly, we can multiply second row of B with all three columns of A as well. First of all, second row will be multiplied with the first column, then with the second column, then with the third column. Now it's a turn of third row of B, which will be first multiplied with the first column of A, then with the second column, then in the last with the third column. As you can see, the product of BA is completely different than the product of AB. So, it's very much clear now that matrices are not multiplicative, commutative. So one should be aware of it that the product of AB is not equal to product of BA. There are some noticeable properties of multiplication which you have to remember. But remember, AB is not equal to BA. But is there any possibility, any situation in which we can have AB equal to BA? Yes, it is possible in one case. In order to understand this, you have to first of all recall about identity matrix. What is identity matrix? It's an n into n matrix with ones on the main diagonal and zeros elsewhere. For example, this is an identity matrix with an order of 3 by 3. All of its diagonal elements are 1. All of its non-diagonal elements are zeros. What do you think? What will be the answer of the product of matrix A into product of matrix I? You can solve it by yourself as well. You can find it out that the answer will be A. It means that A into I is equal to A. Now what will be the answer of I into A? Again, the answer will be A. Therefore, we can say that multiplying a matrix by the identity gives the matrix back again. No matter if you are finding out A into I or I into A, the answer will remain as A. So can we find a matrix to multiply the first matrix by to get the identity? Of course. And it is only possible if you are having an inverse of that matrix. For example, this is the inverse of this matrix. So if we multiply both of them, the answer will be an identity matrix. No matter in which order you are multiplying them. So now we can say that let A be an n into n matrix, or we can say a square matrix, and if there exists a matrix B such that AB equal to BA equal to I again here we mean identity matrix, then we call this matrix the inverse of A and denoted by A inverse. Again I am repeating it. If A into B equal to B into A is equal to I, it means B and A, both of them are inverse matrix of each other. We can solve equations as well in matrices. For example, consider this question. We are having a matrix which is getting subtracted by 2 into a matrix A, then equation become equal to a matrix. We can solve it by bringing the rightmost matrix on the left side of the equation by changing its sign. 2A will go on the right side of the equation and its sign will be changed. Just like we have discussed in our previous lectures, we can subtract these two matrices by subtracting their corresponding elements. Now, as you can see, it was a result of twice of matrix A. So in order to find out the matrix A, we have to cross multiply this 2, and this will go on the left hand side of the equation. It will become 1 by 2. So now therefore A will be calculated or will be found out or obtained by multiplying this matrix with 1 by 2, which means that now it has become a case of a scalar multiplication. So now half will be multiplied to all of the elements individually, and therefore we get the value of the matrix A. Let's take another example. It can be solved by first multiplying this scalar number 2 with all of the elements of this matrix. Then afterwards, each corresponding element will be added with its corresponding element. 10 plus A, 6 plus B, 4 plus C, and so on. Now we have to recall one thing, that when two matrices are equal, then we can equate their corresponding elements, which means that we can equate 10 plus A and 9 because they are corresponding elements. 10 plus A equal to 9. After solving for the value of A, we got A equal to -1. 6 plus B and 12 are also corresponding elements. Therefore, we can equate 6 plus B and 12. After solving for the value of B, we can have B equal to 6. Similarly, 4 plus C and 6 are also corresponding elements, so we can equate them as well. And solving for C, we can get the value of C equal to 2. In the same way, 0 and D are also corresponding. Therefore, D equal to 0. With the same reason, E is also equal to 8 and F equal to 11.